Hello and welcome to the virtual polymer science training for the APOLLOPEX program. I'll be your trainer, Product Manager Holly Hoover. What do hula hoops, milk jugs, and PEX pipe have in common? We'll get to the answer shortly. By the end of the course, you should be able to define PEX, know what a polymer chain looks like, define cross-linked and thermoset, and explain the difference between cross-linking methods A, B, and C, as well as know which method the competitors use. Here's the answer to our trivia question. They are all made from high-density polyethylene. Polyethylene is a popular material. You can see the chemical formula contains carbon and hydrogen. The smallest unit is a pellet, and collectively the pellets are referred to as resin. High-density polyethylene is a versatile material used in a variety of applications from milk jugs to PEX piping. You can see from this list, high-density polyethylene is also used in many applications essential to our everyday lives, anywhere from industrial to automotive to food packaging. High-density polyethylene was originally discovered in 1930, but the process wasn't scalable or economical. In 1951, two scientists, pictured here, discovered an easier way to manufacture high-density polyethylene. In 1954, they commercialized Marlex high-density polyethylene resin. Sales of Marlex resin were slow until a children's toy, the hula hoop, gained popularity in the 1950s. Some say the hula hoop paved the way for advancements in industrial tubing. Let's look more closely at polymer science, which, simply put, is the study of plastics. PEX is an acronym that means polyethylene cross-linked. PE stands for polyethylene, X stands for cross-linked. But what does cross-linking do to the high-density polyethylene? The picture at the top is a representation of an HDPE molecule. When you get multiple molecules together, they form polymer chains. Polymer chains that aren't cross-linked look like these lines on the left. When you cross-link polymer chains, you form connections between the polymers. You can see the new connections better on the right. Once cross-linking occurs, the originally soft polymer becomes a thermoset that has been cured by cross-linking, which transforms it into a rigid material. To review, milk jugs are made from regular high-density polyethylene and can be recycled, soft polymers. PEX piping is made from cross-linked high-density polyethylene and cannot be recycled, rigid polymers. Blow molding is used to form milk jugs, and extrusion is used to form PEX pipe. Two very different processes result in two different products made from the same material. Cross-linking methods. The top left picture shows natural or virgin resin. Color compounds can be added to the natural resin to produce the red, white, and blue colors. Other compounds are added for UV resistance. All polyethylene is not UV resistant. The resin is fed in an extrusion machine, similar to the one pictured here, and subjected to heat and pressure that forms the pipe. These machines can run constantly to produce singular runs of tubing up to 1,000 feet. Cross-linking is an additional process to the extrusion of PEX pipe. There are three methods, A, B, and C. A, B, and C are not grades. A, B, and C are types of PEX pipe cross-linking methods. Europe was the first to use PEX in applications. The United States adopted PEX in the 90s after using polybutylene tubing in the 70s and 80s. PEX A is the angle method. PEX B is the Silanol method. PEX C is the electron beam method. Please pay attention to the icons. They're meant to help jog your memory. With the Engel method, the chicken came first. In 1968, Robert Engel invented the method to chemically cross-link high-density polyethylene using hydrogen peroxide. His idea for radiant heating came from heating the air in chicken coops so that the hens would lay more eggs and avoid the risk of open flame by running hot water through tubing in the floor. He later partnered with Worsbo Uponor to produce the tubing. The Engel method is a chemical process using hydrogen peroxide. Using a special extruder with a plunger to bathe the pellets, the resin is then subjected to heat and pressure, and the peroxide evaporates during extrusion, cross-linking the molecules. The process yields a pipe that can be gently reheated and relies on its material properties to be expanded over fittings for a fastening method. Manufacturers include Uponor, Rayhow, Heatlink, and Sioux Chief. PEX B is the silanol method, where they connect a silane molecule to the high-density polyethylene. Using a standard extruder, the pipe is formed. Post-extrusion, the pipe is exposed to either steam or hot water to finalize the cross-linking process. It offers the highest chlorine resistance and can be fastened by crimping. It cannot be expanded. Manufacturers include Apollo Valves, Bow, SharkBite, Sioux Chief, Zurn, Nibco, and Viga. PEX C, or the electron beam method, is not as popular as the first two methods. The PEX pipe is produced in a standard extrusion machine. Then the finished pipe is subjected to a high-powered electron beam, or E-beam for short. The E-beam connects the carbon atoms, cross-linking the molecules. It's also fastened by crimping and cannot be expanded. Nibco is the only manufacturer at this time that offers both PEX B and C. Let's review what we have learned. PEX A is the angle method. Manufacturers include Uponor, Rayhow, Heatlink, and Sioux Chief. PEX B is the silanol method. Manufacturers include Apollo Valves, Bow, SharkBite, Sioux Chief, Zurn, Nibco, and Viga. PEX C is the electron beam method, and Nibco offers both PEX B and C. Congratulations! The course is complete. You should be knowledgeable about the following topics. If you need to review, simply replay the webinar. Thanks for attending.